print out any data that matches a regular expression to the console just while you run it, so you can get an idea of the sorts of data that are present in the cache. And then it also supports overwriting of cache entries. Okay, so I've got a little web server running, and let's assume that somehow we came across a Memcached server out on the internet. We know nothing about the server. We just know that it's present. So we run our tool, goderpa.rb. The site happened to be called footballfans.com.ui. Interesting name. We run it, and it goes through and it pulls out all the information and it stores it locally on disk. The thing that's of interest is here's a URL that one of our regexes has found. So we go, hey, a URL within the data. This may point to where this particular cache has been used. We browse to that URL, and what we find is a fan page for a soccer player, Luis Suarez, who plays for Uruguay. And he's known for crushing Ghana's hopes at the World Cup, really. He played second goalkeeper when in fact he's a striker, which is, if you know soccer, kind of illegal. Anyway, so we find this guy, we find this page online. And when we look inside this cache entry, what's interesting is that it's not actually the same page. So what we found in the cache is a page that links to the fan page. Okay. But the fan page sits on the same site. So we take a guess and we say it's possible that we have already pulled down the cached entry. We just didn't have a regex that showed it to us on screen. So we search for a string that's in that particular page, and we find that there is in fact a cached item that contains this page. Right. So we open this page, and we decide that actually we don't think he's the greatest goalkeeper. What we do think is he's possibly the most shameful goalkeeper. And we decide that that photo that we had of him is probably does him too much justice. So now what I've done is I've written this copy, or I've written this cached item out into my local disk, but actually what I want to do is I want to write it back into the cache on the Memcached server. And so as I say, goderpa supports that as well. So basically just point it to the file that you edited, say, write that. And now when anyone hits the site, what they do see is a changed entry. Now it's important to note that we haven't changed any backend database information. We haven't edited the page itself. All we've edited is the entry in the cache. But because that's the first place that gets checked to see whether that content exists or not, this shows up on the site. And so that's actually quite powerful. What's really interesting, of course, is that there's no logs here. So when an attack like this occurs, it's really hard for an administrator to track down where it's coming from, because he's going to check database and he's going to be checking pages on the site, and they're all clean. So this is quite a hard problem to debug if you're trying to clean up. Okay, so that's mining the cache and how we can write data back into the cache. There's two issues though. And the first issue is that you first have to find caches out on the internet. This is all well and great. You've got a cache. I've showed you like a dummy application. But actually, what are the probabilities of finding caches on the internet? And so I didn't know. I chatted with some colleagues, and basically they said, you don't really stand much of a chance, because that's not how Memcached is deployed. So I went with a simple approach. I took the network of one cloud provider, and I just scanned it for port 11211, and with a modified Nmap script. And that actually was moderately successful. But there's a second issue, and that second issue is once you find a cache, how do you figure out which website uses that cache, or which application server uses that cache? Because you see a cache sitting somewhere on the internet. If it's just data, it's hard to figure out where that data finally pops out. Right? And so you need to find a way to link caches to sites where they get used. And the way that was most successful for us was to just trawl through all the entries within the cache until you start seeing content that you can either Google for or URLs that you can browse to, which is pretty low tech. The second thing, though, that we found was that when it comes to the content, most of it is rubbish, as you'd imagine. Like lots of the content, from an attacker's perspective, is just useless. I saw enough top 10 scores for Facebook games to last me a lifetime. But if anyone wants to get top 10 scores on Facebook games, I suspect I can help you out. And then the second, or the last thing there, is to determine whether or not that cache data is fresh or live. So we came across caches that clearly had data in them, but weren't actually being used by the web servers that we thought they were being used by. Cool. So some of the results that came out of this. So scan basically a class B, and what we got out of that was just under 230 cache servers, which is almost 1 per 256 IP addresses. That's much higher density than I would have expected at the start of this. As I say, it's a lot of caches, actually. So from that, we pulled down 7.3 gigs of data. The average uptime amongst all the caches was 50 days, which I thought I could infer something from that, but I realized that actually it's pretty meaningless. It just means that people don't reboot servers. More interestingly, though, if you total the bandwidth across all of those caches, you hit 9 petabytes of data, which is a fair bit of network traffic. Across all the caches, 288 million objects were stored, 136 terabytes in total of data stored in mem caches that we saw. So to take that 7.3 gigs, actually we've got quite a long way to go before we get it. But I guess the high scores are more interesting for our purposes. So one cache had done 247 terabytes of data over the network. But actually, there was another cache that had 133 million objects in it, which was almost half the total. Highest number of bytes, 19.5 gigs or so. So what were some of the things that we saw in there? Well, what you would expect on websites: HTML, JavaScript, data. Data was interesting. We had email. We had passwords in clear text. Some of them were encrypted. Some of them were MD5 hashed. Also found objects of a whole... actually loads of objects, serialized Java, serialized Python, Active Record, and so on. So let's talk about some of the actual sites. And they range, well, kind of, I hope it increases a bit. There was a kids game site called GlobWorld. Within their cache, they had the users and the usernames and passwords stored in clear text in the cache, which is pretty lame, so get access to that thing. If anyone uses GoWalla, it's a Foursquare competitor, I think. So it's a location-based service. Hit their cache. In their cache, they've got usernames plus hashed passwords. But they don't salt the password. So take the password hash, plug it into Google. There's a password. Go to GoWalla, log in. There's this guy, his GoWalla account. So there were lots of entries for GoWalla users. Basically, all their user base is cached in Memcache. You'll notice that I blacked out his eyes. Apparently, that's an important thing to do. He can't be identified now. Next one was Bitly Pro. So Bitly is a URL shortening service. They also have a pro version of the service. Their Memcache was exposed, hit their Memcache, also got hashed passwords, also got usernames here for TechCrunch, which I guess is a bit interesting. The passwords didn't work. Well, the hash passwords didn't work. We weren't able to figure out the clear text version. I guess that's a matter of time. But what did work was the API keys that they had stored in the cache. So that's just a request that we made to the Bitly Pro API using TechCrunch's API key. Next one was, or the last one that I'll show you, is PBS. So PBS, the TV station, PBS, or TV network. They had loads of memcaches exposed. So this is just one of their pages, same page at the bottom, that pulled information out of the cache. If you don't see it, we were able to write into the cache. So there's just a little logo appears. Now, of course, this could be anything malicious, right? So this could be some kind of malware or whatever, or link to malware, or redirection to malware. So there's quite a nice way to attack clients here. But actually, there's a better way to attack servers as well. So some of the objects that we saw were serialized Python objects, pickled objects. And if you know anything about Pickle, and before this I knew nothing about Pickle, go read the docs. developers are really clear. As of Python 2.3, all protections were removed from the pickle mechanism. So it's considered completely insecure for unauthenticated and untrusted input. And the reason for that is because it uses a virtual machine to unpickle or deserialize the data. So what you've got there is a little piece of pickle shellcode which was published by the guys who did this initial discussion. So we can really quickly take our, so I just want to reset this so we're all at the same point. We'll populate that. We'll pull out all our entries again. So we're going to alter one of those objects. Okay, so again, I've got this saved locally. I'm going to write this back into the cache. So that's a pickled object we're writing back into the cache. Now, this works because Django uses Python pickle and we're using the Django framework. So when we hit the site, you notice it errors out. That's not a good sign. But if we go into the logs of the web server, you'll notice here we executed the hostname command and it ran and outputted into the web server logs. Okay, so actually what you've got here is remote code execution through Python pickle through an exposed memcached server. Now, that thing breaks, which isn't so special. Let's see if we can get it to not break. And so what we'll do is the same thing, but we'll make our Python. What we're going to do is to alter that payload a little bit so that actually we don't get any errors out of this. So we keep the original object in there. We make some minor changes to the payload so it doesn't terminate early. Write that back into the cache. This time, all going well, the page doesn't break. But if we go back into the web server logs, we get there, our command still executes. So now we can get reliable execution without errors, without notifying anyone through the memcached. Okay, so we did that. We spoke about that. Fixes, obviously it's simple. Firewall that stuff off. It shouldn't be exposed. If you have to expose your memcached, edit out your stats, the stats code in the server, also with the debug features. Try switch to Sazzle if you can find a library that supports binary protocol for your platform. Salt your passwords. Please, come on. This is 2010 and people not salting their passwords. Also firewall. A few random thoughts. The one thing is this cannot be new. So memcached has been out there for 7 years. I haven't seen public work on this stuff, but that's too trivial for this not to be known somewhere. If you know someone who's done this stuff, please come talk to me. So there's other options going forward for finding, I think, finding the cache where you can't find URLs. If you find HTML, inject images into that you control, look for referrers and so on. And I think that if you take out the stats commands to find the keys, there may still be options for key guessing or prediction. So that's basically where we'll keep on going with this research in the next couple of months, I suppose. Are there any? So the code's up at that site. If you are at all interested or run memcached, you can get that site or get the code at that site. Are there any questions? Not this. Cool.